Hi everyone, welcome back. We are continuing our work in Module 1, Topic 2, Lesson 4, page 103. This is Activity 2, page 103. Okay, so it's on prisms and pyramids. The base of a prism is not always rectangular. It can be a triangle, a pentagon, a hexagon, and so on. Okay, so it says a few things here, and I'm going to highlight and underline and kind of mark this up a little bit, make it a bit easier to read. Says a pyramid is a polyhedron with one base and the same number of triangular faces as there are sides of the base. Go ahead and highlight that or underline it, whatever you have available. So if I think about that, so this is a pyramid. So it's a polyhedron. It has one base. That would be the part right down here. Here's the base. And the same number of triangular faces as there are sides of the base. So this base has 1, 2, 3, 4 sides, and we can see 4 triangular faces coming up. The vertex of a pyramid is the point at which all the triangular faces intersect. So that's going to be right here. Well, that is the vertex. A slant height of a pyramid is the distance measured along a triangular face from the vertex of the pyramid to the midpoint of an edge of the base. Let me explain what that is telling us. So we see a dotted line here and the little right angle symbol. So that's one of the things that clues us in that this is a height. We've talked about that. So it says a slant height of a pyramid is the distance measured along a triangular face. Okay, so it's along the face from the vertex of the pyramid to the midpoint of an edge of the base. So the midpoint of the edge of the base, if this is the edge of the base, the midpoint is the middle. So it goes from the vertex to a point on the base that's in the middle. So it's this dotted line right here. I'm just going to go over in blue. So that is the height. All right, moving on. Number 1 says, locate the nets for the triangular prism located on page 111 and the triangular pyramid located on page 113. So I have those here and here. Triangular prism and triangular net. So as you notice in the prism, we have a series of rectangles and the 2 triangles. So prisms have rectangles that join the 2 bases. The bases are the triangles. The bases name the shape, and we talked about that in class. Here we have a triangular pyramid. So the triangles here at the bottom. Now we know that in a pyramid, all of the faces that are not the base are triangles. So if these are faces, then it has to be a triangular pyramid right here. Okay, and I actually have some of these cut out from some cardstock. So I have this one, and I have this. Okay, let's just move these pages here out of the way. So, and just to kind of go back up to the prisms at the top, the base of a prism is not always rectangular. It can be a triangle, pentagon, hexagon, and so on. I don't like that they didn't really cover the prism very much. Every single one of these shapes has rectangles that connect the faces. The bases, sorry. Rectangles connect the bases. And just like we had in our notes, the base names the shape. At least it's one part of the name. So let me just kind of go over this part really quickly. It's not on here, but I do want you to know this. So the first thing that I'll have you name is whether it is a prism or a pyramid. So prism. So prisms have rectangles. That connect bases. Well, and there are two bases. Pyramids have triangles that attach to one base. So the first thing you're going to ask yourself is it a prism or a pyramid? And then once you have that figured out, then you'll look at the shape for a prism. Like in this yellow one, we can see the rectangles kind of going up and down here. And then I can see two shapes that are the same that are not the rectangles. Now you can have a rectangular prism. Then that shape would just have all rectangles. So that shape is a five-sided figure, so that's a pentagon, so we'll call that a pentagonal prism. The rectangles here kind of go around, the side wraps around, and we see the base is a triangle here and a triangle on top, so that would be a triangular prism. 1, 2, 3, 4, 5, 6, 7, 8. So 8 sides of that shape. That's at the top and at the bottom, so that'll be an octagonal prism. This has triangles that meet at a vertex and connect to the sides of the base. So we know pyramid from all of the triangles meeting at the vertex, and then the size of the base is the shape of the base is a square, so it is a square pyramid. Okay, so cutting and folding and taping of these shapes. One second, just lost my tape. I've got it. So I already cut these shapes out. So when you cut them out, they have little flaps to be able to kind of hook them together. So I crease on all of the black lines, the solid lines. The dotted lines are our flaps to fold with. And notice how it just kind of fits together here. And I'm just going to tape that a little bit right inside there, give it a little bit of stability. And then bring this side up. I'm going to tape that up here. Okay, so this one has the vertex and triangular faces that are connecting it to a base that's also a triangle. And this one, so I see, so the flaps aren't counting. Like we're not going to look at the flaps really. They're not part of the shape. That's what helps us to put it together. So the net itself looks like this. So it has rectangles that are connected by two triangles. So it's a triangular prism. And when we fold it together, There we go. So we have rectangles going around the side here that connect to triangles that are on opposite sides. The bases are always congruent, the same, opposite and parallel to one another. So if I were to set it on its base, I'm going to set it like this. Okay. All right, so let's answer the questions. Number 1B says, identify the number of bases in each solid. Describe the shape of each base. So the triangular pyramid and then we have a triangular prism. Okay, so we have the two. Triangular pyramid, so that's this one. So the number of bases in each solid. Now, I do realize that we can really set this one on any side, but whatever side we're setting it on, we're going to call that the base, because the definition of the pyramid is that the faces all meet at a vertex and all of the faces are triangles. So therefore, this only has one base. It would be there. So the triangular pyramid has one base. The triangular prism, oh, and that base, it says, and describe the shape of each base. One base, triangle. The prism, we know it's a prism because it has rectangles that are joining two shapes that are the same. So how many bases does it have? There's one triangle we can set it on, and there's the other. So it has two bases, and the shape of the base, again, is a triangle. Identify the number of faces in each solid. Describe the shape of each face. So the triangular pyramid, how many faces that are all triangles? Well, 1, 2, 3, 4. Remember the face and base. A base can be a face. Because, right, it can fall on its face. Even if let's say I labeled it base. Right? Remember we said you can identify a base because something can land on its face. Or I'm sorry, you can identify a face. Because it can, if I try to balance it on the edge, it can land on its face. Okay, so the number of faces in the triangular pyramid, I'm just going to keep it kind of right down here. Say everything on this side is triangular pyramid, and everything on this side is triangular prism. So you don't have to rewrite that over and over and over. Okay, so there are 4 faces that are triangles. They're all triangles. And for the triangular prism, so we said this is a base, and then opposite is a base. So if I just count these, if I call that side 1, and that's a 2, I want to make sure I'm not over counting or under counting. I'll make sure I get it all. 3, 4, 5, and then I'm back to one that's already counted. So this has 5 faces. And describe the shape. So there are 1, 2, 3 rectangles, which makes sense based on the definition. It told us that we're going to have the number of faces coming off of the base has to be the same as the number in the shape itself. It just doesn't make sense for it to not. I can't have a 4th face coming off of the bases, and I can't have less than that, or it wouldn't be a complete shape. So there are 1, 2, 3 rectangles connecting the two triangle bases. What's the difference between the number of bases of each solid? Well, the prism has one more than the pyramid. Because this one had 4, this one had 5. What's the difference between the number, I'm sorry, that's bases, 1 base, 2 base, and then it says faces, and that's going to be the same thing. Has 1 more base, and the prism has 1 more base in the pyramid. Okay, pause if you need to finish writing. Label each net with the name of the solid it forms. Okay, so I see triangles and one other shape. So in a prism, I know rectangles connect the bases. So if I only see one rectangle, then it's probably not a prism. So would all of these triangles be able to meet and form in one point at a vertex? So yeah, could you imagine folding each of these triangles upward? So we know it's a pyramid. And then what shape is the base? It's a square. So it is a square pyramid. Okay, so for the next one, I see rectangles and 2 triangles. So if I'm seeing rectangles and it looks like it's connecting the 2 different triangles with a rectangle, then I know I'm looking at a prism, and the 2 sides that would be the same are, and that are not the rectangles, is the triangle. So it's a triangular prism. All right, it says draw a net to represent each solid figure. So if I were to unfold this, I'm going to think about this part here along the bottom staying put. So if I just kind of draw that here, and if I picture what happens if I unfold it, so I'm going to imagine unfolding it along this line right here. So if I kind of unhook it here, and then I unhook the sides here and here, here and that side back there. So if I unhook those, like let's say I just kind of cut it down so I could unfold it and back here, then coming off of the side is going to be another rectangle. And off this side will be a rectangle. If I had this as the base. And then those triangles would be attached to that base. So they're going to come like this. And if you notice, we just recreated the same thing. Triangular prism as a net, triangular prism as the solid figure, and then here's the triangular prism that we made. Okay, so what about this one? Well, I see several triangles that come to a point. So I know it is a pyramid. So I see the faces of the pyramid connecting to the point, and then I'm going to look at the base at the bottom, which is a triangle. So it is a triangular pyramid, which is this one. There's the base and the triangles. All right, moving on. Using nets to calculate surface area. The net of a solid figure. Actually, I'm going to pause this right here, and I'm going to start it as a new video for activity 3. That way it's not quite so long and it won't take as long to upload. So if you're going to continue on to activity 3, hop on to the next video and pick it up from there, please.